Here's an example from our homework. It's related to chapter 3.4, but I will also include some 3.5 discussion since this homework assignment's together. And so in this first situation, you have this set of data, and in this case it has to do with the miles per gallon a car gets. And each car has even though it's the same car, they have slightly different values. And so in this case here, you're looking for z-scores, quartiles. And so z-scores again are a measure of how far you are away from the average. And you do that through standard deviation. So you need the mean and standard deviation first to calculate a z-score. And again, the best way to do that, not by hand, is you have the data. You would use your summary statistics on this variable of data that was opened up. And then you would just do mean and standard deviation. You could use variance. Again, there's other values here, which we're going to look at again. And so mean, the other one is standard deviation. And then if you look ahead, I'm looking for Q1, Q2, which is the median, Q1, Q2, Q3. The median is Q2, quartile 2, the 50th percentile. We have range. There's also IQR. There's also other ones here. These unadjusted standard deviation, that's the population standard deviation. Just keep that in mind. Min, max. So we can get all these different values, how many in the data set you compute, and you get those values there. So that's again from summary statistics. And then you end up with the 5-number summary, which is chapter 3.5. But the same, again, it's related to quartiles, percentiles. Again, Q1 is the 25th percentile also. And so if you went back here in the summary statistics, again, I had all those that I've chosen. You could also put in here percentiles. Look, if I put 25, 50, 75 in here and compute, notice that those values there match up to Q1 is the 25th percentile, Q2 or the median is the 50th percentile, Q3, 41 and 40 match up. That's just another way. The quartiles are very specific percentiles, and the percentile is again what percent of the data is below this value. So out of this list, we would say 25% of the values are less than 36.9. That's what we're saying there. And so that's how you would go ahead and answer these questions here. Interquartile range is Q3 minus Q1, which is what we got from this data here. You could see also it's here, but you can subtract those two. Another thing you're going to do from 3.5 is to graph a box plot. And so that would go graph box plot, the one variable there, and compute. I like to draw the boxes horizontally there. You could show mean and mean if you want. And then you can see you get a box plot, the spread of the data. This one looks a little bit skewed right. The tail's longer here, but it's mostly symmetric there. And you see you can get the values that way also. So just keep that in mind as you're using StatCrunch and doing these sections here. The other question that comes up is outliers. And so we have this definition. So know that you should be able to do it by hand. This is from the textbook here, the 5-number summary we're talking about. But for outliers, in order to calculate an outliers, you do need to use this formula if you're going to do it by hand here. And again, outliers are those values that are far away from the average. And how do we determine if it's far away from the average? You need to go ahead and calculate these. And so in this example, you can see from the textbook how to do that. Make sure you know that, how to do that by hand there. But additionally, again, if we wanted to do this, you could also say use fences to identify outliers. Click, and you can see now that this value here, which is the maximum value for this data set, is an outlier. It's outside of this box plot. It's an adjusted box plot. that shows you where the outliers are. You don't always have outliers. This one does. But again, that was from clicking here, use this. I don't put that until I'm looking for outliers. You can see there's the data set, but now we know that that maximum value is an outlier. That's it.